Hi friends, let us try to calculate derivatives of some simple functions using the rules that we have learnt. Sum rule, product rule, quotient rule, power rule, etc. Okay, we have R as a function of theta. Right, R is a function of theta. Now we have to find dr by d theta. Right, so we can express this like 12 theta power minus 1 minus 4 theta power minus 3 plus theta power minus 4. Right. Now, this is a function in the form of u1 plus u2 plus u3. Right. Now, and we can use the power rules here. What is our power rule? X power n derivative is n x power n minus 1. For x power n, the derivative is n x power n minus 1. And when a constant is multiplied, a function is multiplied with a constant, we'll say derivative of this is c, we'll bring c outside and do the derivative of this function. Okay, we will use both of this. So here 12, 4 and 1 are constants. And theta power minus 1, theta power minus 3, theta power minus 4 are of the form x power n. So what we'll do, 12 we'll take it outside into minus 1 theta power minus 2. Right. n x power n minus 1. So minus 1 theta power minus 1 which is minus 2. Right. Minus 4 times minus 3 theta power minus 3 minus 1 which is minus 4 plus minus 4 theta time theta power minus 4 minus 1 which is minus 5. Right. Please note n x power n minus 1 n theta power n minus 1. Okay. So that becomes this one minus theta power minus 2 minus into minus 5 which is plus theta power minus 4 12 theta power minus 4 and minus 4 theta power minus 5. Very simple. Now here we have again y as a function of x. In fact, y is a function of u and v. U of x and v of x. So what is our formula? D by dx of uv is u dv by dx plus v du by dx. Right, we'll take one function at a time and then differentiate the other function. Right, let us use the same methodology. Or what is the other method? Other method is we do the product of this and then do the differentiation of the product, whichever way we choose. Okay, so here in this case, let's try with the first method. That is taking the first function and differentiating the second and taking the second function and differentiating the first product of this. Right, so for example, this one, first function, this is u and d by dx of v, x plus 1 plus v, then again du by dx. Right, we are using this. We are using this method. Now what happens to this? X square plus 1 and d by dx of x, which is 1, plus d by dx of 5, which is 0 because 5 is constant, plus d by dx of 1 by x, that is nothing but x power 1, which is nothing but minus x power minus 2, the derivative, right, n power n x power n minus 1. So minus 1 power x power minus 1 which is minus 2. Right, which is nothing but 1 by x square. Right, so minus of 1 by x square, which is nothing but 1 minus x power minus 2. This part, right. Now, x plus 5 plus 1 by x, that is x plus 5 plus x power 1, times d by dx of x square, which is again x power n, which is equal to, this part will be 2x, because d by dx of 1 constant is anyway 0. Right, now if we simplify this, what will happen? X square, my x square into 1 x square into minus, or x square into minus 1 by x square, which is minus 1, plus 1 into 1 into minus x square, that is this, and 2x into x, which is 2x square, plus 2x into 5 10x, plus 2x into 1 by x, which is 2. Right, if we simplify this, what are we getting? This 2x square, this x square, which is 3x square, and then this 10x, and then minus 1 plus 1, this will get cancelled, and minus of 1 by x square. Right, this is what we have done when we are taking u and v separately. Right, now let us do the product first. If we do the products, what will happen? X square into x square, which is x cube, then 5x square plus x square and 1 by x, which is x, plus 1 into x, which is x plus x, which is 2x, plus 1 into 5, which is 5, plus 1 into 1 by x, which is 1 by x. Right, now we have this in the form of u1 plus u2 plus u3 plus u4 plus u5. which is when dy by dx will be equal to, right, d by dx of u1, d by dx of u2, whatever, like this, right? So this is the sum formula. Now d by dx of x cube, which is nothing but 3x square, right? 5x square, 5 into 2 into x, which is 10x, 2x, it is 2, for 5, which is a constant function, which is 0, 1 by x is minus 1 by x square. So we got this function, right? The derivative of this function, which is same as this function. 3x square plus 10x plus 2 minus 1 by x square. So basically, if you do the product first, or if you take these two as separate functions and do the differentiation using the product rule, we'll still get the same result. Of course, it depends on the ease of the situation. Then we will do whichever way we want. So this function is actually derivative of this function. What does that mean? This function gives slope of this function of y. Slope of y at whichever x, at whatever x that we choose. At x equal to 2, if you want to find the slope, then we'll just input x equal to 2 in this equation, right? So wherever this function, wherever we want to find the slope, we can use this function to find the slope, right? Now let us look at this function, 1 plus x square, x power 3 by 4 minus x power minus 3, right? Here also it is product of two functions. You can do the product first and then apply the differentiation and then differentiate, or you can differentiate using the product rule, that is d by dx of u equal to u dv by dx plus v du by dx. Okay, let us try to use the both methodologies. First one, u, that is this one, this is u, this is e, dv by dx, right? This is nothing but 3 by 4 x power 3 by 4 minus 1, that is nothing but 3 by 4 x power minus 1 by 4. Here minus of minus 3 x power minus 4, right? Minus 3 x power minus 3 minus 1, which is nothing but minus 4. This minus into minus will become plus 3 x power minus 4. Similarly, this we will take v first and then du by dx, which is nothing but this one will anyway give 0, constant function, and this one is 2x power 2 minus 1, which is nothing but 2x, right? Then if you simplify this, what you will get? This one, 3 by 4 x power minus 4 into 1, which is 3 by 4 x power 4, right? And 3x power minus 4 into 1, which is 3 by x power 4. Then x square into 3 by 4 x power minus 1 by 4, which is nothing but 3 by 4. Then x square into 3 by 4 x power minus 1 by 4. This becomes 3 by 4 into 3 by 4 into x power 2 minus 1 by 4. 2 minus 1 by 4 is nothing but 7 by 4. Right, that is this part. Then here x power 3 by 4 into 2x, which is nothing but 2 into x power 1 plus 3 by 4. That is 1 plus 3 by 4 is nothing but 7 by 4. Now these two terms put together. 3 by 4 plus 2 x power 7 by 4 into 3 by 4 plus, again this one we can write as 8 by 4, right? 2 is 8 by 4, so 8 plus 3 11 by 4 x power 7 by 4, right? Now 2x into 1 by x cube, right? The final one, right? This 2 will get 2x power minus 2, right? Minus 2 into x power minus 3 plus 1, which is minus 2. And here, this one and this one, they have given us 3x power 2 minus 4, which is minus 2. So 3x power minus 2 minus 2x power minus 2 is 1x power minus 2, which is nothing but 1 by x square. So basically, we have used the product rule here. Instead of product rule, if you do the multiplication first, 1 plus x square into x power 3 by 4 minus x power minus 3. This becomes 1 into x power 3 by 4. This is x power 3 by 4 minus 1 into x power minus 3, which is this. Then x power 2 by 4 into 3 by 4. That is x power 11 by 4 minus x power 2 minus 3, which is x power minus 1. Right. Even now, this is in the form of u1 plus u2 plus u3 plus u4. Right. And all everywhere x power something. That means you can use power rule. So this we can easily do. Right, dy by dx is 3 by 4 into x power 3 by 4 minus 1, which is nothing but x power minus 1 by 4. That is this one. Here, minus of minus 3, which is plus 3 into x power minus 3 minus 1, which is x power minus 4. That is plus 3 by x power 4. And here 11 into x power 11 by 4 minus 1. That is 7 by 4. 11 by 4 into x power 7 by 4. Minus of minus 1, which is plus 1 into x power minus 1 minus 2, which is 1 by x square. So this one and this one, they're exactly same. So whichever way we choose, it will get the same result. Whether you do the product first and do the differentiation, or you take these two as different functions and do differentiation with respect to using this formula. Then also we'll still get the same result. Right, guys? Only thing we have to see is this function is also differentiable. This function is also differentiable. Obviously, there are no zeros in the denominator. There is no discontinuity. And these are some of functions which individually are continuous and differentiable. So one is continuous, obviously it is differentiable. X square also, x power 3 by 4 also, x power minus 3 also. So as long as x is not equal to 0, we can differentiate these functions. If at x is equal to 0, we have 1 by x cube. Here also we have 1 by x. Right. So these functions are differentiable as long as x is at all points except when x equal to 0. Right, guys? Hope you like this. Thank you.